Hello, everyone, and welcome to another episode of Open Observability Talks. I'm your host, Dotan Horovits, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. And on today's episode, I have something very exciting. For the past years, essentially, I've been covering eBPF and how it can help us realize true automatic instrumentation for observability. And then a few months ago, there was a significant step in that direction under the OpenTelemetry project with the addition of OpenTelemetry eBPF instrumentation, or as we call it, OBI, based on the Beyla project donated by Grafana Labs. I invited Mario Macías, principal software engineer at Grafana Labs and co-creator of the Beyla project and OBI, to tell us all about this fascinating project. So I'd like to welcome you, Mario, for joining me on this episode.
Thank you, and thank you for inviting me to this podcast.
Yeah, pleasure having you. And, I said about it, I've been talking about the potential of eBPF for observability for years. Even here, by the way, on the show already, I think 4 years ago, I hosted folks from the Pixie project. Now it's a CNCF sandbox project that uses eBPF for Kubernetes monitoring, and then folks from Polar Signals about the Parka project that uses eBPF for profiling. And I even had an episode about the OTel Go auto instrumentation with the city of Odigos. So I was really excited to see the Beyla project donated to the CNCF and becoming part of OpenTelemetry. So first and foremost, congratulations to you and to all the team involved.
Thank you. I think it was a natural movement to just donating it back to OpenTelemetry.
Yeah, and we'll definitely hear about it. And actually, you're a veteran of observability. I didn't mention all your titles, but you've been working in New Relic and Red Hat and now Grafana Labs. So you're an observability veteran. So maybe you should start by you telling us how you got to eBPF and the observability agent space.
Okay. It was just a coincidence. I got into eBPF. In a previous employer, we were working in a network observability solution, and we needed to get data about the network flows. There were already some solutions working that didn't use eBPF, like software-defined networks for Kubernetes, or even the data that net flow data that many routers, switches, and other hardware devices provide. But we observed that there was still a gap to miss. In the sense that not all the software-defined networks provided this information, and even some software components didn't perform well. They get overloaded when they try to provide information about all the network flows. So we started experimenting with eBPF. So it's worth mentioning is the NetObserve project. It's in OpenShift, but it doesn't work. It doesn't require OpenShift. It might work in other platforms, and it got an instant success internally because we were able to provide, with a very small software component, we were able to provide a complete set of network flows and a complete set of all the network flows going through the system without or with a minimal impact in performance. So it even became the default proposed solution rather than other information coming from SDNs. From that, I jumped into Grafana,
And that's before OpenTelemetry's networking performance monitoring. For those who know it, it predates many years before that.
Yes. And then I saw a project that was being planned into Grafana. I found it very exciting. So yeah, I just sent my CV And it was pretty fast. Then I landed into Grafana, and we started with we wanted it started as a Go. It started as a Go application monitoring solution using eBPF. So that's why we started working and trying to contribute to the existing OpenTelemetry Go instrumenter, which was an already solution, a solution already being created. But at some point, we started
I
to
should mention,
diverge.
by the way, sorry to
Um,
that, we actually had that for our listeners who are interested in hearing a bit about background of that. Actually, this is one of the episodes I had, I think, three years ago already, about the OpenTelemetry Go auto instrumentation and the SIG, the special interest group that started around that. So if you want to learn more, I'll add the links to the show notes. Check them out. Sorry, carry on.
cool. Good point. Yeah, so at some point we started to diverge. In instead of focusing on Go and auto instrumentation, we started to focus on generic auto instrumentation of any kind of application, and also started adding some extra signals like process information, network flows. So we considered that it was difficult to keep contributing to the OpenTelemetry Go instrumenter, just because we started to be different, like following different paths. So that's why we created Grafana Beyla. We still kept trying to contribute some improvements in Beyla that could fit to OpenTelemetry Go. We start to or we try to contribute them back, but we started to differ, so we decided to fork and create a new project.
And now it's sort of the closure of a circle, because it started as a fork of the Go auto instrument, and now it's back in OpenTelemetry. I even put my OpenTelemetry shirt, especially for the occasion. But as a new incarnation, I guess. So the Go auto instrumentation SIG is still there, but now there's a new SIG running. Fast forward for our listeners, we're jumping in history, but sort of now it's part of OpenTelemetry, as I said, as of I think earlier this year, a few months ago, I think back in May 2025, that it was approved, and there's now both a code base and the SIG, the special interest group that focuses on and instrumentation, essentially, eBPF instrumentation, right? OTel eBPF instrumentation, is that the formal name?
Yes, yes, it is. Actually,
Yeah.
we have as maintainers, we have some maintainers in common with the OpenTelemetry Go instrumentation. So they are still two different projects. At some point, we would like to incorporate some of the features of OpenTelemetry Go instrumentation that we might still miss in OpenTelemetry eBPF instrumentation.
Yeah, but let's take a step back. We ran forward because you and I are already in the details. But let's take a step forward and really explain to our audience that is not familiar neither with Beyla nor with OBI about really what OBI is about. What's the mission? What's the main purpose? You started hinting, alluding that about the types of information collected. But let's do it like give us the elevator pitch for OBI.
Okay, basically OBI allows you to instrument your applications. What I mean by applications, I mean usually clients or services, and provide what we call red metrics, that is rate, errors, and duration. So you instrument at the application level the details of the communications between your applications. From that, this is not very different from any other OpenTelemetry SDK. The particularity is that Beyla doesn't require to reconfigure or rebuild, redeploy your application. You just drop OBI there, and it will use a technology that has been for some years in the Linux kernel named eBPF. eBPF basically allows you to inject some probes, some small programs into different parts of your system. So they are triggered. It's like a code-based debugger. Those endpoints those probes are triggered on certain events. For example, when a new socket connection is open, when you receive traffic, when a given user provided function is triggered. So from those endpoints, when those eBPF programs are triggered, we can read the memory. So we can see what's going on and start reconstructing information about your system traces. So
I think it's important to emphasize that it happens in kernel space. So although you monitor the applications in this case, but it runs, and this is part of its powerful qualities, is that it runs in kernel space, right?
Yes, it runs in kernel space. So you will need some privileges, some extra privileges to run OBI, so it can hook into the kernel. Particularity of eBPF is that it's a just-in-time virtual machine that pre-verifies your code. So it takes care for potential dangling pointers or null pointers. So it can make sure it won't load your program unless it makes sure that your program is safe. That prevents you from hanging your system if you load an eBPF program with a bug.
And that's very important because, as I said, it's kernel space. On the one hand, it's very powerful because you have direct access to a lot of the information on the protocol, the endpoint invoked and on. But then again, if something is messed up in the program with its kernel space, it doesn't crash just your application; it crashes the entire thing. So I think the safety measures there are definitely a crucial feature of eBPF.
Yes. But I think we never hung. Even developing, we never hung the kernel. It just you just say that your program crashing, saying, "Wait, this is not. We cannot verify the safety of this code." And I'm pretty confident deploying eBPF software.
So yeah, and obviously it's an open source project, obviously, for the eBPF, and as you mentioned, it's baked into the Linux kernels and actually expanding beyond Linux. So it's pretty because of the ecosystem that has been built around it. I think it's definitely much more robust than maybe 4 or 5 years ago when I started covering it for these use cases. And I want to go back again to OBI, again, OBI for OTel eBPF instrumentation, just for those who haven't picked up on the acronym. And essentially, so you instrument the app layer. I'm just summarizing for our audience. Although it's a program running on kernel space, it essentially provides you auto instrumentation of your applications running, whether server, service, or client, and the communication between them. And providing you mentioned the red metrics, so the request rate, error rate, duration, the classic golden signals that everyone works. So it gives sort of the baseline telemetry that people usually want for basic monitoring of their application, right?
Yes. Just to be a bit more precise, OBI is not fully running in the kernel space. It's another user space application with few privileges, so it can load small programs in the kernel that will store this information in a data structure, in some data structures named eBPF maps. So from the application layer, it reads all the information and then reconstruct the traces and provides all the metadata. So 99, 95, 98% of the CPU time is spent still in user space, and most of the code is still at user space. But yeah, you need those small part of the codes running at the kernel.
Yeah, and I think important to add for those who haven't had the chance to deal with automatic instrumentation, with auto instrumentation, is the value of no code. As you mentioned that before, no code without code changes. This is very, very crucial because for those who have tried to do the manual instrumentation directly with the OTel APIs, that's a lot of code that you need to add beyond your business logic. So here we're talking about something that is a no-code instrumentation, right?
Yes, yes. I think the main advantage of OBI is the no code. So, and you can get instant instrumentation from the very beginning without having to instrument everything and redeploy it. The other advantage is the performance. Uh, uh, Compared with some SDKs, for example, for Go, for Java, you might have current SDKs might be performant enough. But we observed, or some users complain that in some the SDKs of some interpreted languages might add an extra overhead because all this code, all the instrumentation code is running in the interpreted language. So with eBPF, since this is just in time compiled, you can also with low latency instrument or get basic instrumentation of your services, even if they are written in Ruby or Python or other interpreted languages.
Nice. Actually, it's interesting. Can you share with us which languages can people use already now OBI today?
I think it will support. I'd say it's language agnostic because OBI what does it for some compiled languages like Go, it hooks into the application, into the user executable, so we can get more, we can get richer information. But for generic languages that we hook into the operating system sockets and also into the libSSL library for secure communication. So from there, the eBPF programs will read all your information. So we got use cases from users using even OBI or Beyla to instrument R languages. We didn't know that R, the statistics language. We didn't know you could write you could use it for writing web services, but yeah, it seems even R. So it's fun. We got use cases we didn't know there were possible. Currently, the only limitation we have is for secure Java services, because for plain HTTP services, Java works well, but for secure Java services, to instrument secure traffic, we hook on the libSSL library, which is written in binary, so we can get data from there. From Java, since Java uses its own TLS library, and that TLS library is written in Java, written Java bytecode is really, really, really complex from eBPF, because you get the bytecode, but the bytecode then it gets compiled into binary, but then it might be recompiled again for optimization. So that's pretty difficult. This is something we still don't support. For the rest of languages in Linux, yeah, I'd say we can get basic instrumentation.
Nice, and it's important. So, and again, we talked about the benefits of running in kernel spaces. So, effectively, even if your communication is encrypted on the kernel level, I don't know if you use HTTPS, TLS, all these things, the ability to run in kernel space also gives these advantages of being able to still have access to the code. Again, it is privileged probes that get that, so it's not something that you share with everyone. But for the purposes of the instrumentation, you can actually address the payload, even if it's on user space it was encrypted. So
yes, it's a matter to know where to pick the data. For normal traffic, you can get it at the socket level. So you see all the socket data, all the data going through your socket, you see it raw. But for secure one, you need then to pick in the libSSL library just right before the data is sent for encryption or after the data is received and encrypted.
yeah, makes sense. And we talked about the languages. I think another aspect that I find interesting in OBI is also the multiple protocols that are supported. Do you want to say a word about that?
Yes. Uh, sometimes I want to clarify that sometimes people thinks that eBPF is some kind of magic. So you tell eBPF, please bring me the data, and you get all the data. But this is not real. What you see from eBPF is just a bunch of bytes. You need to know how the data is structured at the binary level. So if you want to support new protocols, you need to explicitly add them. It's not like, for example, in an SDK, you are with traditional SDKs, you are working at the programming language level. So you get the information, you know which arguments you have, you can code in your target language. With eBPF, it's a bit more difficult. You work in C, you just see a bunch of bytes. You need to understand them. So you need, for every new protocol, you need to add explicit protocol. We started with HTTP and HTTPS, which are the most common protocols, and expanded it to gRPC. But recently, thanks to OBI being open source, we are having new contributors that are expanding the number of protocols like Kafka, MongoDB. We already provided SQL, but now the SQL support has been expanded and improved. I'd say that even we have Redis. So yeah, the number of protocols is growing. So if you listen the podcast episode few months after it was being recorded, you will probably get new protocols. Hope so.
And also, if you find it useful and you miss one specific, I don't know, your database, I don't know, MongoDB, I think is supported, but I don't know, some other database or some other framework, and it's missing. This is a great opportunity to chime in and at least open an issue, maybe even contribute. But the portfolio of supported protocols, I think, is one of the strengths of a true multi-language, multi-protocol instrumenter, generic instrumenter, which is the mission statement of OBI essentially. So
yeah, we are always very welcoming anyone jumping into the CNCF Slack or into the OBI GitHub repo and suggest new features, new protocols, even report bugs.
yeah, that's a value of open source. And we talked about the red metric. So I guess the principal value is the metric signal, but I know that you're exploring other signals as well. Do you want to talk about traces?
Yes, we are providing traces also. Trace support is still a bit limited, so we manage to support distributed tracing. As long as you get red metrics, you can get single spans. So you get a single span. But for distributed metrics, distributed traces, being able to propagate the context through traces, this is a bit difficult to do from eBPF, because this involves not only reading the information, but also writing the information, modifying the user request to attach this trace parent. This is not possible in all the languages, especially in secure communications, because you cannot rewrite the output. But we managed to get some tricks to relate when we measure separate spans. We did some tricks to try to relate them and then report them as part of the same trace. But we should see case by case whether it is support or not. Same as red metrics are generally available, traces, it's still a bit more limited. We hope to keep expanding also the tracing support for more frameworks.
By the way, I think the original Go auto instrumentation agent had tracing in it. Of course, it was language specific. It was just Go, but it did tackle tracing, right? If my memory serves me right.
Yes, it did. It did tracing, but also as far as I remember, there were also some limitations. And something that is happening also is that we implement tracing, but then using a given Linux kernel feature. But at some point ago, maybe 1 year ago, I don't remember exactly when, they decided that this Linux feature in eBPF should be disabled because it's insecure. So they broke distributed tracing. We had to re-implement it using another tricks. But yeah, they initially, and I guess I'm sorry, I haven't followed that project lately. I don't know if they probably they still support it, but I don't know the details about how they support it.
No, it's okay. Just trying to remember, but from my earlier explorations. But I think one thing, and maybe just for the audience who's not fully familiar, to give context, what the difficulty that Mario was talking about is essentially, I guess the uniqueness of tracing as a telemetry is the context propagation. The fact that it's not you just emit one off like a metric point or a log. You need to actually propagate the context. You need to create this relationship between a parent span and a child span, and that they're all part of the same trace, all based on IDs. But the thing is that it's very important when you emit a span to get this metadata that gives this context. So just for the audience who's less familiar, this is what you attach when you do that via SDKs. The SDKs are in charge of adding and managing this, both the context propagation, the assignment of this metadata, the span ID, the trace ID, and so on. But as we said, when you need to do that sort of in a way of a reverse engineering or sort of hacking it into the code when it's already in compiled code, then the challenges arise. So just to give a bit more context about why it's such a non-trivial challenge engineering-wise, and it's interesting to hear. And also, I think you talked about frameworks, but it's important to understand the proposed architectural challenges that frameworks comes with their HTTP server implementations or whatnot, and you also need to adapt to these potentially changing implementations, even if the end user doesn't even realize that some things were changing underneath the hood, right?
Yes, and that's some part of the fun we got because when you code, when you manually instrument something in your code, you know when a function starts, when a function ends. So insert there the probes, and that's it. In traditional frameworks, thinking some traditional HTTP framework in which every request is handled by the same thread, it's also relatively simple. You know when the request starts, so you add another probe when the request ends. So you say, okay, this request started in thread give X, and this end in also I'm still in thread X. Then they are the same request. I just measure the start from the start and end time and get it. With modern frameworks, I mean asynchronous frameworks, this is a bit different because a single thread can handle thousands, millions of requests from the same thread. So now being or staying at the operating system level is not feasible. You need to go to the framework implementation level. So, for example, for supporting Node.js, we need to know how the Node.js event loop works. which data structures do they use internally, with the added complexity that those data structures, for example, Node.js or even in Go, you need to know not only the thread. The thread is now useless. You need to know the Go routine. But in Go, you can spawn Go routines without caring too much. So you need to rebuild the tree of Go routines to try to relate all the requests and start and the end. So yeah, it's you have to know it. It's a bit more difficult. You can implement it, but if at some point the owner of the library decides to optimize and re-implement it in a more efficient way, upgrading your library might break your instrumentation. So we need also not only to detect which frameworks or which languages are you using, we also need to detect which versions of those libraries are you using, and then sometimes providing different instrumentations.
I think it's a good point, because you said before at the beginning that many people think that eBPF is sort of a magic, and yeah, you just you go underneath the programming language in the kernel level, so suddenly everything becomes flat and everything becomes you're agnostic to the language. But there's a lot, because the frameworks are so intelligent, so optimized, and they do a lot of smart stuff to be efficient, and it happens in the framework level. You, as the developers of the agent, need to know a lot about the individual frameworks in order to support them. So I think it's important to have a realistic look at eBPF and adjust expectations, first of all, in terms of the end users that think, yeah, I inject something in the kernel level, ultimately everything is a a binary, or everything is ones and zeros, so there's no problem. No, it's much more complex than that. And you gave us just a taste of your daily, you and the other maintainers daily, but I think it's good to also adjust expectations from the users.
Yes, exactly. It's important to be honest and don't overpromise. That doesn't mean that OBI is very limited or is unstable. No, I think that it performs pretty well. But not talking about OBI, but eBPF in general for any other task. You need to get a very deep knowledge of what you are touching in order to get it properly working. Some fun anecdote was that, for example, a few years ago, the Go compiler changed the way it passed arguments to the function. So instead of passing arguments in the stack, they started passing arguments in the as registers. So that broke most of the existing instrumentation, because when we were instrumenting some functions, we expected that some values, some arguments were at some locations that they stopped working anymore. So we had to also not only detect the libraries, but also for Go programs, detect which compiler version they use in order to take the arguments one way or another.
Yeah. The fun thing about developing agents, and for the the guys in charge of deployments in our organizations that might be intrigued with that, but immediately say, okay, what does it look like in deployment? So can you give us a bit about what you actually run to actually get this magic and these goodies in your application?
Yeah, so basically, you deploy Beyla as a single executable in your node, in your physical node. Beyla, OBI. I still I'm still used to the old name. That actually exists. We can talk about that later. OBI basically starts or loads a lot of probes into your operating system, as we mentioned before, in sockets, in the libSSL library, but also in the case of Go, in your Go executable, it will also look for some functions and start adding there some small programs that run every time this function starts or ends. This single program, that is OBI, that runs in the user space, basically takes listens for any new process that comes, or any existing process, or any new process that is triggered into your system, and then verifies if it has been selected for instrumentation or not. So to not generate too much noise, you can configure OBI to say, okay, I only want to get processes from this using this given port, using this given executable, or also you can select them by Kubernetes metadata from this deployment, from this pod.
Nice.
Then it will basically just listen only for the events coming from those processes. It will get the basic trace information, and then it will decorate it with some extra metadata like Kubernetes metadata, and then it exports it as OpenTelemetry or Prometheus. OBI also supports network flow informations that is agnostic to your application. You won't see application level information, but for some custom protocols that don't get direct support from the SDKs, you still can know that is data flowing from one endpoint to another into your cluster.
What kinds? Yeah, can you give us concrete examples just to understand what kinds of use cases you found useful for that?
Yeah, for example, one is a use case not at the application observability level, but at the network monitoring level. You can get flows, or the flows going through your cluster, the communication between aggregated by node, by process, by pod. So you get similar to NetFlow information, and it's also useful for example, to monitor your network costs in your cluster. You can see external network traffic, but also you can see traffic in your cluster within different availability zones, which have an extra cost. So you can do this kind of measurements. Also,
Nice.
we found some users coming saying, "Hey, this OBI is inventing the data. They are showing me this. Look at this service graph. This is showing data that is not that shouldn't be. That those connections shouldn't exist." And then we discovered that maybe this piece of software that became from a third party was using some gossip protocol to communicate between different instances. So it makes you be aware of some traffic that cannot be seen via traditional instrumentation because you might miss it.
It's not surprising. I can tell you that with basic tracing, not even eBPF, very standard tracing, it's amazing how many times I see when the company instruments tracing and they look at the service map for the first time and then say, are these two services communicating? I've never known that. And sometimes it's the architects, so that actually they're supposed to be like the oracles of the organization around the architecture, and they're not aware that there's a path that communicates between these two. But yeah, I can show you the span. I can show you exactly the invocation, which operation and when, and the parameters. So it's crazy how, when you're actually not looking at static architecture diagrams, but actually at what runs in production, you can discover a lot of things about what runs in your system.
Yeah, that's right. That's we tend to think in logical connections. So the services speak to this another service, but then when you start adding intermediate message queues of service meshes and so on, you get this real network communication that maybe you weren't thinking about it, or you weren't considering, taking into consideration.
Yeah, and going back to the production setup, so just for our audience, essentially, so you have the eBPF probes that are, as I mentioned, as you mentioned, loaded on the kernel level and capture the network, the process, the application telemetry, and then there's the user space agent that I guess processes and coordinates all this data, and you run it as a daemon set, as a sidecar? You mentioned it on the same node, but is there a preferred way, or what does it look like in production?
Yeah, the preferred way is as daemon set. So you, from one single instance, you will instrument all the processes in your system, the ones that you selected. Sidecar mode is also supported, so they run in the same pod, and this OBI instance will only see data of the pod where it is located. We generally recommend daemon set mode because it's more efficient due to economy of scale and it's simpler deployment. But it might happen that you only want OBI for a very concrete application that is not deployed in all your nodes, only in a few subset of them. So you consider that it's not worth deploying something globally. So in that case, you can deploy it as a sidecar, so you will only get few instances instead of having one instance in every node.
And in terms of metadata enrichment on the telemetry, does that happen on the kernel side, on the probes, or more likely probably on the user space on the agent?
Yes, it happens in the user space of the agent. The agent has to connect to the Kubernetes informers, to the Kube API, and get a snapshot of all the metadata into your system. So when you get the raw data from the kernel, you only get information about process IDs, basically, which process ID you have. So then you need to do some match this process ID with your container ID. So once you get that container ID, you can match it with the Kubernetes pod
And
deployment and so on. Yeah, there is some internal matching.
And another point that you mentioned briefly, just want to pause on that, the side of the exporting the data to backends of choice. You mentioned Prometheus, you mentioned others. So which backends are supported? Where can I today send my data, and in which formats?
You can export for metrics information. You can export it in Prometheus, but our main exporter is OpenTelemetry. So you can export it in
OTLP.
to any OTLP endpoint. Yeah.
Sounds good. And for tracing, I assume also it will be OTLP based, right?
Yeah, OTLP. Yeah, we don't support any other exporter. It could
Sounds
be
good.
easily added, but I mean, we didn't get anyone asking for that. We are actually inside the OpenTelemetry organization, so we are focusing mostly on OpenTelemetry.
Yeah, that makes sense. And are there any, beyond that? So I want to just go back. So there is the code base. Essentially, there was Beyla under the Grafana Labs, and then you. It's not really that you donated Beyla. I think it's a wrong because Beyla still exists. So you donated the significant code base off of Beyla, which is the basis of OBI, and Beyla still exists. So do you want to help us figure out exactly the relation here, or what Beyla is after the donation?
Yes, we've got many times this question. We wanted to donate Beyla to OpenTelemetry, but there were some parts of Beyla that wouldn't fit into that project. So we donated 80-90% of our code to OpenTelemetry. So all the basic application and network level instrumentation, the code relies on OBI. So OBI is feature complete. Everything I've mentioned until now runs in OBI, but there were some other features that we still wanted to keep. So Beyla is still existing and provides some extra features like process level metrics, an easier seamless integration with Grafana Cloud, for example, and is the downstream distribution of OBI that Grafana is commercially supporting, despite we are still contributing to OBI. Actually, the warranty that they won't separate paths is that all the code we donated to OBI has been removed from Beyla. So now Beyla, OBI supports running as an executable, but it can be also run as a library. So Beyla uses OBI as a library. So when we want to add a new feature to Beyla, we need to add it first to OBI. An improvement, any bug fix. So once it's in OBI, it is automatically incorporated into Beyla.
That's great. So, and Beyla carries on. It was the Apache 2.0 license, and it carries on the same license and just focuses now on, as you said, the sort of downstream from the OBI with the specifics of adaptation to Grafana Cloud and your commercial offerings, and also with your commercial, I guess, SLAs and guarantees, right?
Yes, just to clarify, also in case to avoid any misconception, OBI works with Grafana or Mimir or the OTel endpoint, so you don't need Beyla to use Grafana. And also Beyla will still work with any other provider or any other vendor. So yes, so because both at the end use OpenTelemetry are bounded to OpenTelemetry standard. It's just this extra set of features that are provided by Beyla, but doesn't prevent you exchanging one or another from one vendor to the other.
Sounds good. So I want to talk a bit about the SIG, the Special Interest Group that was founded. Again, the name is OTel Instrumentation SIG. By the way, you can find it. There's a dedicated Slack channel for the SIG on the CNCF Slack instance. We'll put all the links on the show notes. Can you tell us a bit about the SIG, its charter, its status, the work there?
Yeah, so the SIG was, as you say, created in May. We started with some administrators and maintainers from other companies. So we have Grafana as the initial donator, but now and we got some extra contributors and maintainers from other companies like Splunk, Odigos. Yeah, but
Coralogics, I think, with some of the protocols, right?
Yeah, Coastly also, but then just right after we create the SIG, Coralogics joined and started to do some nice contributions. Yeah. Nice. So we are happy because thanks to that, now we are even Beyla is more feature rich than it would have been before the donation, because now we started to get some contributors. We meet every week, so we have a SIG meeting that is open to anybody wanting to join. We often get people in the SIG from Google, Red Hat, many other. I'm sorry if I forgot other companies. Okay. So we are always open for people chiming in, asking for feature requests, having doubts, etc.
Yeah, so maybe it's a good opportunity to mention. So if anyone wants to chime in on the discussion, as always, and definitely in the CNCF, it's open for all. So you have the weekly calls. You have, as I mentioned before, the Slack channel where you can for the async chatter, and obviously there's the GitHub repo. Any other places where you'd advise people to go to?
We still have some people coming to the Grafana Slack in the Beyla channel. Sometimes they are asking things about OBI, so we are also there. If you are not in the CNCF Slack but in the Grafana, you can come to the Beyla channel and even talk about OBI. It doesn't have to be restricted to Beyla. And also the Beyla GitHub is still active, and we are still receiving their some suggestions, back reports, and so on.
Although as a CNCF ambassador, I'll have to encourage everyone to join the CNCF Slack. It's open, by the way, for all. You don't have to work for a company that is a sponsor of CNCF or anything else. The CNCF Slack is open for anyone and everyone. And once you're there, again, you have the designated Slack channels for different special interest groups and working groups, and obviously the projects and tools. So it's a great place that will serve you also much far beyond this specific topic. So encouraging everyone to join the CNCF Slack for this and other contexts. And really, I was really happy to hear about the different companies or maintainers from different companies joining, because this is the power of open source, and seeing folks from Splunk, from Odigos, from CoreLogics and others. These are the good signals. And I saw the stats on the forks. I think you even posted it on the SIG channel, and seeing the graph going. So how many found it interesting enough to fork and play with that? That's great initial signals for a new project. I did want to ask you, zooming out on the OpenTelemetry. So I mentioned before already 3-4 years ago, and you also were engaged with the Go Auto Instrumentation. That is another piece of the monstrous big OpenTelemetry project. And there are other SIGs. So Go Auto Instrumentation is one SIG. There's the profiling SIG. There's the collector SIG. There's the network performance monitoring, and other pieces. So when you join, you're the new joiners, but I'm sure that this is a discussion that is part of joining took place, maybe also with the technical committee and the governing committee. How does that fit in together, or going forward? Okay, this is new, but a few years from now, what would be the overall view of OpenTelemetry into instrumentation and telemetry?
Basically, I think I guess this will differ from one company to another. If I understood well your question,
it's more on not on the company level, but on the OpenTelemetry project side. So what will OpenTelemetry as an open source project will be the statement? What will be the architecture, the convergence maybe between the different SIGs? So that's the question.
Yes. So at this point, we are planning OBI as a first shot to get the basic information about your system. We always recommend that if you want to go beyond, you need to use the proper SDK. So it's not a replacement for existing SDKs. It's just some complementary information to get instant basic observability. There is still some collaboration to start doing between OBI and SDKs in order to enable in the future seamless or letting them working together without duplicating information. So you can get, because even if the SDKs are more complete, there is also some information that can be seen from eBPF that cannot be seen from the SDKs, like internal runtime information, network level information, and so on. So we would like to get both SDKs and OBI working together without, for example, duplicating information. There's also some work to do with the system metrics SIG in order to standardize those. The network metrics we already provide are not standard, so we will need to provide a proper semantic convention so OBI works together within the OpenTelemetry ecosystem.
Sounds good. And you mentioned already about the SDK, so maybe this is a good segue to talk about roadmap. So beyond obviously the official release that is the immediate focus, can you tell us anything about what's upcoming for the project and the SIG beyond that, and the
Yeah,
SDKs that you mentioned?
yes, on one side, we are working on expanding the number of protocols, the number of languages, the accuracy of the data, the improve the tracing, the distributed tracing support. But also another point to start working is to let OBI working better, interacting better with the SDKs. Currently, what we have is that if OBI detected that an application is already being instrumented with an SDK, OBI will ignore the telemetry coming from that application, just to avoid generating duplicate metrics. At some point, we would like to detect that, and instead of stopping the instrumentation, start enriching the OpenTelemetry data that is provided from that SDK, from that application, enriching it with better or fine-grained information.
Nice, very nice. And as we are approaching the end of the show, I did want to mention we're now in October and we're November, just a few weeks ahead. We're going to have KubeCon North America in Atlanta. So first of all, for all our listeners, if you're not aware and you're somewhere in the area and you're still interested, go quickly and get your ticket before it's fully booked. And also, it's a great place, like any KubeCon, to meet maintainers, SIG leads, and anyone involved, contributors, anyone involved in the cloud native ecosystem and the CNCF stack. And specifically, I'm sure that you will be there. I know you already mentioned it to me and maybe other SIG members. So do you want to tell us if there are going to be any specific talks about the OBI or any other places where they can meet you or others and talk about this more?
Yes, we will be in the. You can find us in the CNCF booth, OpenTelemetry booth there in KubeCon. I'll be personally, but some other colleagues from Grafana and from the OpenTelemetry SIG will be there. So I think maybe most of us will be there. There will be a few talks about OBI. For example, I'm giving a talk about what is this extra information that you can get with OBI and eBPF that you cannot get directly with the SDKs. Yeah, but I think there are at least 1-2 more talks about OBI.
Amazing. So check out the talks on the KubeCon agenda, or look specifically for Mario's talk by speaker name. Definitely should be interesting. And I'll also, as part of the show notes, I'll list the contacts where you can reach out to Mario on social media, LinkedIn or whatnot. Any beyond that, and obviously on the both the CNCF Slack and the Grafana Slack, any other place that you'd advise people to reach out to you?
We usually attend to many conferences,
Yeah.
but personally, I mean, I will advise reaching us in the CNCF Slack or in the GitHub. They are the most active sources. Of course, if you want to have some personal, you want to personally reach in, you can find me in LinkedIn.
Sounds good. So thank you very much for joining me, Mario. And also want to thank all our listeners for joining us for this fascinating episode. Really exciting news about this new addition to OpenTelemetry. And as always, all the episodes are found on your favorite podcast apps or on YouTube. So go check them out, including the episodes that I mentioned we had before about other eBPF-based tools such as Parka and Pixie and the others that were covered here on the show throughout the years. And you can follow us on social media, on Blue Sky, LinkedIn, X, to get more updates about the episodes, about chat in between, and follow up feedback about the episode. So feel free to follow us there. And of course, if you loved the discussion, feel free to share it with your friends. I'm Dotan Horovits. Thank you very much for listening. And until next month's episode, may the open source be with you.